All right, how's everybody today? Doing all right. Hey, it's Friday. I got a weekend coming up. Next Friday's the end of the 6 weeks. Got your tests graded. I will pass those back in just a little bit. Class average 82.2, so nicely done. If there's any questions, I've got a snapshot of those. I can go ahead and talk to you as soon as I pass those back. But I think we're only a few minutes away from finishing up the lesson. The homework is what you picked up on the way in today. Let's say Monday on that. Okay, let's have that due Monday, and then I'll have a little exit ticket for you guys to take care of before you leave as well. So let's see. We were talking about relations and functions. Then we talked about functions using the vertical line test, domain and range. Okay. And I think we got 5 done. Okay. I think all we have left is 6 and 7. All right. Well, let's take a look. For the function f of x. Now, this right here, what did we call this yesterday? Or the day before, excuse me. F of x. What kind of notation was that? That's function notation. Okay, whatever's in parentheses, that's your x. That's an element in your domain. But f of x is the range value. That's your y. Okay, so we're told that f of x is equal to x cubed plus 1. And we want to go ahead and find f of negative 3 and f of 1, given that x belongs to the reals. Okay, so f of negative 3. Okay. What do I do when you have function notation like this? What do you ask to do? There you go. So every value of x is going to be replaced with that input. So x cubed is going to become negative 3 cubed, and then we have our plus 1. There you go. So given this x, what's the y value that corresponds to it? What is a negative 3 cubed? Negative 27 plus 1 will give me negative 26. There you go. And you could use this to go ahead and get points and go ahead, get your graph if you wanted to. But this would tell me that the coordinate negative 3, negative 26 exists on that graph. Okay. The input and the output we got, the x and the y. And I'll do the same thing for the 1. So f of 1. So x cubed becomes 1 cubed plus 1. Well, what would that be? Okay, it's just 2. Because 1 cubed is just going to be 1. 1 times 1 times 1. All right. And then number 6b, the element of the domain that has 65 as its image. So what it's saying here, it's another way of saying that 65 is the output. 65 is the y value. So if I were to go ahead and, set this equal to the function. Okay, so this time we're kind of reversing the process. We know what we're going to get out of it, but what x would I plug in to get that 65? Okay, there you go. So let's just go ahead and subtract through. X cubed would equal 64. And how would I get rid of a cubed? Cube root. There we go. They would be inverses of each other. Now, the thing about an odd root, how many solutions does it have? Just the one. And it's always the same sign as what? As the whatever you take. There you go. What do we call that expression below the radical? Starts with the R. Radican. There we go. Just think, when you're doing one of these, if you get stuck, I radican do it. We never say radicant. Right, Caroline? Yes. Right. Okay. But remember, if you're dealing with an even root, like a square root, fourth root, then you have 2 solutions, positive or negative. Okay, so x equals 4. Yes, very good. Okay. Number 7, this is our last one. So graph y equals x squared plus 1 over x squared. So this one is actually really nice. If I were teaching Algebra 2 again and we were going through our rational functions, I would absolutely go ahead and use one of these. But I'll go ahead and leave it up to you guys. How much of this do we want to do by hand versus how much do we want to do just plugging it in the calculator? because you probably could go ahead and determine the domain by hand, but depending on your background, you might have a little bit of trouble trying to figure out what the range is, because you'd have to use a little bit of calculus. In fact, I am going to teach this to you. We just haven't talked about it yet. Has anybody ever heard of what's called a derivative? Okay. Sydney, you remember I taught you about those?
Yeah, it's also calculus.
Yes. The difference quotient? Do you remember the difference quotient? No? Okay. All right. So I'll let you guys decide. What would you like to do? You just want to go ahead and plug it in the calculator at this point? Okay. All right. So let's see here. Now, one thing I am going to do, I am going to go ahead and pull these together into a single term, because right now we have a binomial, and I want a monomial. Okay. So let's see here. So before I go ahead and do that, hopefully this will help with the graph that we're going to have. So let's say I have x squared, okay, over 1 plus 1 over x squared. Okay, well, the common denominator has to be what? Okay, it's got to be x squared. So I'm going to multiply this by x squared. Okay, so this is going to give me x to the 4th plus 1. That's power. I wrote that down a little too far. There we go. Over x squared. Okay. Now kind of think back to your rational functions. Anything that makes the denominator 0 is where the function is going to be undefined. Now, when we're talking about rational functions, any value of x that makes the denominator 0, what do we call those? Starts with an A. They're represented by dashed lines on your graph. The graphs will get infinitely close to them, but never touch. Asymptotes. There we go. Okay, so asymptotes. Okay, now wherever the numerator is equal to 0, can anybody tell me what that is? That's where the function is. No? That's where you're going to find your x-intercepts. Okay. So on this one, let's go ahead and set the numerator equal to 0. Like x to the 4th plus 1 equals 0. Well, what do you notice as soon as I subtract the 1 over? How would I get an x from x to the 4th? Take the 4th root, but I'm taking an even root of a negative number.
So it's imaginary.
It goes imaginary. So what's that telling me about x-intercepts? This graph should not be crossing the x-axis. Okay. What's the only value of 0? What's the only value of x that this graph cannot have in the denominator? 0, because you can't divide by 0, right? Okay. So where should we have a vertical asymptote? The y-axis at x equals 0. Okay, so let's go ahead and type this in, and let's see if that's exactly kind of what we're seeing here. So I'll go ahead and type it in as it is on the paper. So x squared plus control divide. That's not what I meant to do. Okay, control divide. There we go. 1 over another x squared. Okay. And there you go. And if you were to zoom out, you're going to notice that these two inside arcs here, they're going to get closer and closer to the y-axis, but they're never actually going to make contact. How wide do you think this guy's going to become?
Not that wide.
Not that wide?
I mean, it will eventually.
Yeah. Well, I mean, think about it. Is there any value of x that I could not plug in and get a y value for besides the 0? Yeah, this guy's going to become infinitely wide. All right, so what would his domain be? It's going to be all reals. Now, looking at this graph, probably the best way for a lot of folks to do this now, if you're trying to figure out the range, well, we need to know the minimum value. Okay, so I need to know exactly how low. And I mean, looking at it, you could probably tell.
The range?
Yes, where does it start? Looks like it starts at 2. Okay, but just in case you know it might be a decimal value or something, we go to menu, we want to analyze a graph. And we want the minimum. Okay. So I'm looking for this value right here. Okay. Oh, so it's not moving my... Oh, you just screwed up. Okay, that's all right. Nah, it's like my wife is talking to me. So there you go. Okay. I'm making a joke. Oh, I'm not afraid of my wife. Okay. All right, so lower boundary, I'm going to put it on the left. Okay. Upper boundary, I'm going to put it on the right. Okay. And there we go. So the minimum is 2. It occurs at x equals 1. Okay. So as far as what this problem wanted, okay, the domain is all reals. So negative to positive infinity. The range was what again? 2 to infinity. And how do we show inclusion? Bracket. Okay. Just very quickly, does anybody want me to show you how we would find that value by hand?
I actually have a question.
Yes.
Totally aside from that.
Okay.
Wouldn't the domain actually be negative infinity?
Oh, as soon as you said that, yes, I'm sorry. So technically, actually, let me go ahead and go back here. You can either write it like this and then say, x cannot equal 0, or if you're going to write it just strictly in interval notation, that's my fault, negative infinity to 0 union 0 to infinity. Okay. Now you can use the value that makes it undefined as long as you don't include it. Yes, sorry about that. That was completely my fault. Okay. All right. Would anybody like to see how we get that range by hand? I mean, you're not going to be held responsible for this, and it's going to be probably at least a month before I go ahead and show it to you, but see if I want a sneak peek, or are we good?
We'll give us something to look forward to.
Well, you get to look forward to math every day, so you don't.
But now we have
All right, there you go. Okay. All right, so I will go ahead and stop there. Okay, so you have your homework assignment. It is due Monday. Okay. Hopefully this is just a review. We got about, a week and a half, 2 weeks of this, and we'll start getting into some trig. I also would like you to take a look at this before you leave. This is an exit ticket. Okay. So you'll turn this in before you take off today. Okay. It's over the same material, so hopefully it won't be too bad. You guys can work together on that. If you have a question, let me know. And then once everybody has one of these, I will go ahead and pass back your tests. I'll let you see how you did on those. Okay. All right. Is this for missing so many people today? Was this the class the other day that I told those chemistry jokes to?
Yes.
Okay, so I got another one that I heard. So this will also help the people at home feel like they're here, enjoying everything as much as Sierra is, because she's got a huge smile on her face. Okay. Would the chemist invite sodium to his party? Nah. It's Na. Sodium, yeah. I'll stop on that one.